Good afternoon, everyone. Welcome to Virtual TC World Conference. We have over 150 presentations during 5 days and over 2,000 participants joining us from different countries across the globe. Welcome to the third session that's organized as a satellite conference by TechOn Poland. And we have two presenters, Michał Skowron and Paweł Kowaluk from Guidewire Software. And this session is titled DITA as Code, a New Phase of the Old Standard. And my name is Wojciech Relich. I'm a VP of Solutions Engineering at Argos Multilingual, and I will be your moderator today. We also have a technical support team working in the background and making sure that everything runs smoothly. Before I begin, I would like to tell you about the different interactive features that organizers of the conference prepared for attendees. You can ask questions during the presentation using the questions panel of the GoToWebinar application. And I will keep an eye on these questions, and we will have a Q&A session at the end of the presentation. You can also go to the chat section of the GoToWebinar application, and there is a link to the event app where you can continue the discussion after the presentation is completed, after session is closed. So I guess that's all. And Michał, Paweł, good to have you here, and I will just pass the mic to you.
Great, thank you, Wojciech.
Thank you.
Michał, you want to kick it off?
Yeah, sure. So welcome, everybody. As you can see, we are going to talk about DITA as code. So at the beginning, maybe we can tell you a few words about ourselves. I'm Michał, and today I'm presenting with
It looks like we've lost Michał's audio.
I think we lost Michał. I think we
my
lost
colleague
Michał.
and good friend Paweł, that you may know from other conferences. So to cut the long story short, we're sorry, let me try. Okay, I think I'm back. So hopefully it's not going to be a problem. So we're tech writers at Guidewire Software. In our free time, we do other techcom stuff like recording a podcast.
Okay, I think we have technical issues with connection.
Other things. So before we start, we would like you to. Yeah.
Michał, I think let's do this.
Yes.
Michał, can you switch off the video? Let's try it with audio only, and in case we have another audio issue, then Paweł, I will have to ask you to take over if possible.
I'm sorry for that, but I don't know why it's happening.
Yeah.
Okay, so yeah. So before we start, we would like to ask you to answer one simple question. So if you can see the poll, can you just answer if, according to you, can you do docs as code with DITA? And we're gonna wait for some answers from you. Okay, the situation is very dynamic, I can see. Okay, over 50% of the people answered the question. Okay, I think that should be enough. So let's close the poll now. Okay, and so 62% said yes and 38% said no. interesting, but let's leave it like that. Okay, so before we start talking about DITA as code, we want to clarify one thing. It's not like we are saying that DITA is a silver bullet for all your content challenges, or like DITA is better than you know, something else, Markdown or anything else. We just want to talk about it because every time we hear a discussion about the docs as code model, we have a feeling that people are, you can either have docs as code or you can have DITA. You cannot have both, which is pretty interesting because we think in a different way, and we'll try to show you why we think in a different way. So at the very beginning, let's try to define what we understand by saying docs as code, because there are many definitions, people have different understandings, so let's create some baseline for our discussion. So we based this definition or this set of rules based on Anne Gentle's book, Docs Like Code. So the first thing would be storing your doc sources in a version control system. It can be anything like Git or Subversion. Another thing would be
Okay, I think I'm going to take over because we keep losing Michal. Right. So so according to Anne Gentle, the second major point that makes something docs as code is being able to build and publish automatically, kind of like software is deployed automatically without, you know, manual publishing. And then Anne Gentle also mentions that you get a set of reviewers to review the docs, same as you have reviewers review the code. With code, every change is reviewed in a pull request, and the majority or everyone basically has to agree that this pull request is valid, is correct. If you want to learn more, check out Anne Gentle's book, Docs Like Code. For the sake of this presentation, we're going to be sticking to this understanding of what docs as code is. So these 3 points. So docs are stored in a version control system. We build and publish the docs automatically, and then we get them reviewed meticulously and ensure highest quality, just like we do with code. So usually when talking about docs as code, we think about the tools and the workflow. Let's see an example workflow here. Our markup is DITA. Our editor is Oxygen XML. Our static site generator is DITA Open Toolkit. If you think this is controversial, think about what a static site generator is. It generates files which you can put on a basic web server and have a web page. DITA Open Toolkit generates some form of HTML or a web help, right? Or we're not talking about PDF here, but when you talk about static site generators, you talk about HTML. So DITA generates a static HTML site, or DITA OT. And then we use, in this hypothetical pipeline, in this hypothetical workflow, we use automatic validation and testing with schematron and some text linting with Veil. Veil allows you to help out with language, with sentence structure. Sentences are too long, using wordy sentence structures, etc. Veil highlights all of that and helps you write more smoothly. And then we also talk about some custom scripts that we write to support validation and testing. We'll get to that in a minute. And the rest is exactly the same as a basic docs as code model. So it's the same BCS, it's the same CI/CD, etc. But the question is, why do that? Why do you want to write docs as code? What is the reason? And this is a basic question that we always should be asking ourselves if we're doing anything. And we can frame it in terms of goals of docs as code, because those goals will tell us, those are also the goals for our documentation. So if we want to meet them, let's use the docs as code framework or docs as code philosophy. The first key point is achieving better collaboration with developers. in docs as code, you want developers in your doc repository. You want them participating, you want them reviewing, you want them writing docs, you want them fixing errors, deleting stuff which is not correct, testing stuff, making sure it works. Easier maintenance and faster delivery through automation makes docs quicker to get to the customer, and makes it easier on us to get these releases out. We can even get to a point where, you know, traditionally in technical writing we have releases, right? But some software is maintained continuously, and we would hopefully achieve continuous integration with documentation as well. So if the software is updated overnight, maybe documentation is updated the next day and it's live on the server and it's up to date. And achieving that with some other systems which are external is possible, you know, like a CCMS externally, not docs as code, but a hefty CCMS. It's possible to achieve the same, but it is much easier if docs are maintained in the same repository and with the same tools as the code. And then the higher quality is achieved through practices which are, you know, very ingrained in software, which is, you know, linting and testing. Linting means checking as you write, and then testing means after you've written. So let's see how exactly we can accomplish all of that with DITA. And we'll map these 3 goals onto 3 areas of working with DITA, and then we're going to focus on one of them specifically. So to achieve better collaboration with developers, we can put DITA in the same version control system. So for example, if the software is in Git, we can put it in Git. To improve maintenance and delivery through automation, we can use CI/CD with a Docker and DITA OT. And I'm going to show you in a couple of slides how simple and easy that can be. And then higher quality, we can achieve through semantic testing. And this is something we want to focus on because this is something that actually makes DITA different from other docs frameworks. It's different than Markdown, it's different than anything else, or not anything, but most things you can imagine which you can use as the basis for your docs. Okay, so let's take them one by one. Better collaboration with developers by using DITA and Git. It's quick and easy because DITA files are text files. So you could just dump them into a folder and git init, git commit, git push. However, there are some problems which we want to acknowledge, right? DITA has a lot of structure to it, and you have to follow that structure. Because if you use a text editor and you break the tags, you broke them, it doesn't work anymore. And you also have links and keys in DITA, which in Git, there's no native way of validating them. So if you change the name of a file and 50 files were linking to it, they now have a broken link. Same with any other kind of value of keys and cornerfs and conkeyrefs, etc. And then there's no natural way of managing translations in Git. And with documentation, this can be a little tricky unless you're willing to either translate the whole repository every time you need to translate it, or if you have some other tools that you use for managing translations. For example, many software companies already have a workflow for translating code which is in Git, or translating application strings more likely. If you're able to apply the same mechanics, you're okay, and you should be able to manage your translations in Git. If not, you would have to develop a method and methodology of or a workflow of how you can do that. We're not going to focus on that in this presentation. As I said, we want to focus on semantic testing. So let's keep going. But before we get there, automation with DITA OT is a simple command. This is just, this is just one command. When you can use the Docker image, which is published officially by the DITA OT. And you can run this build in, it's fully automated. You just run this command and it builds your documents. It's quick because it's, it uses all the latest features developed in IT, and it works in any CI/CD. Basically, any CI/CD that is out there has Docker support and has command line scripts. So if you can run it you can run it in Travis, you can run it in Jenkins, you can run it in TeamCity, Circle CI, etc., etc. Now, semantic testing. Let's talk about this one. And this is going to take a little bit longer because we got to figure out what it actually is. So we have a simple definition here. Semantic testing in DITA is using the semantics of DITA to test documentation. Right, so we're using the semantics of DITA to test documentation. Semantics in DITA is all the tags which name a component. Right, for example, win title, API name, command name, path name, etc. All of these components are semantics, right? And then testing documentation means making sure that this documentation is correct. So, for example, if in a document you talk about a piece of software, and you talk about what this piece of software is supposed to do, and you list a command, and you wrap it in a semantic tag, we want to make sure that you can run this command against this piece of software, and then the result is going to be what you expected. And this extends to any kind of semantic component, and this extends to any feature of the documentation. So if you're listing configuration values, if you're listing names of functions, if you're listing parameters for a function, anything that you do in a software document, you can map this onto the software that it's supposed to work with. Now, there's no semantics in Markdown is an exaggeration, but maybe it's just 1% exaggerated, because you could say that there is some semantics. You could say that there's a code block, there's a header, there's a line, a paragraph, right? But that's it. For example, if you say result and then colon, it doesn't semantically tell you that this is a result. Like, you could try to parse a Markdown file and keep some conventions, but nothing stops anyone from saying results instead of result, or saying note instead of result, or just stating the result without using the keyword result, right? So this semantic is not inherent to Markdown, and it's not enforced by Markdown. But there is full semantics in DITA, which we've talked about, and this is basically the main selling point of DITA. This is why we have DITA, right? Because we want semantic markup on our documentation. So code semantics, for example, a code block. And if you're familiar with DITA, you've seen this thousands of times. This little tag holds inside a command, or some piece of code, but in this case, this is a shell command which you run. In this specific example, you run some program called converter.sh, and then you pass some parameters. And additionally, apart from just saying it's a code block, we're adding an output class sh, meaning this is a shell script. So maybe you can use that kind of semantics somewhere, and you could add more metadata, because DITA is very rich in this aspect. You could specify even more about this code block. But specifying what programming language it is, or what environment it runs in, is the basic requirement, and this is something that's covered in DITA automatically. So the semantic test could be find the code block with output class sh and run it against the software, which means that in any file that we have in our repository, if there's a code block, we will run the command inside this code block against the software which we are describing. Here's another example of semantics: step result. Step result means this is the result of this step. So, and then in this example, we also have some other semantics, like API name means this is the name of a function or an API or something that we can use in the software. And then also it says the converter creates images in the file path in the out directory, and out is surrounded by the file path tag, which means this is the file path. The word out is a file path. We can write a test which finds the file path in the step result. And remember, this file path has output class output path, right? So find this file path with the output class equal to output path and check if the path exists. And we run this as a single test. So you run the command and then you check if the result exists. If the command failed, the test failed because we used the wrong parameters, we used the wrong executable to run it, we messed up the syntax or something. But if this first test passes, then we run the second test. Is the output folder generated? If the folder is not there, the test fails. If the folder is there, the test passes. And we wrote an example for you, which you can check out later, but this test runs and it says the command is okay and the path exists. Right, so the converter.sh and then convert the folder images from PNG to SVG, it worked. And then the path, the folder out in the relative directory where we were running also existed. The test passed, and we know that our documentation is correct. But it's possible that we run the same test and there's no such file or directory as converter, right? So there was a problem running this command. So we know that there's something wrong with our documentation. Maybe the name of the command or the executable changed, maybe some parameters changed, etc. We have to go back to the documentation and check that. And then specified output path doesn't exist. Well, naturally here it doesn't exist because the command didn't run. But it's good that this test caught it. Another example of this could be where the first part of the test runs successfully, but the second one fails because maybe the output folder is now called test or it's called something else. It's not called out anymore. So we have to go back to our documentation and correct that. And again, this is thanks to DITA semantics. We're keeping in lockstep with the software. So if the software changes, this test will tell us that something changed critically. Now let's talk about some more examples about path semantics. Let's say we have a file which lists configuration files, and it says there's a configuration file called config.json. In DITA, we put it in a we put it in the file path tag. So for each file path, verify if the file exists. We're running this test on a specific DITA file, reference file, which lists all the configurations. And then in the same file, we have parameters. So it tells us that in a specific file, there's a field maybe called quality, and it has this description. So for each PT, now look back at the semantics. We have a parameter list. There's a parameter list entry, and PT is parameter term quality, right? So parameter term. So for each parameter term, verify if it exists in the file from file path. So we're testing two things. The file exists, and then within that file, any parameter that we listed in the documentation is actually in that file. Here's an example of running this test, and path is okay, config.json exists, parameters are okay, resize, filter, quality, and then another path, converter.sh. Now let's see this test failing. Okay, so we got two problems here. Parameter filters does not exist in the config file, and the parameter quality level does not exist in the config file. As a technical writer, now I know that there's an error in the docs. Maybe the parameter was renamed, removed, or moved to another configuration file. This is, part of my job to fix that. We can also apply semantics to a spell check. Your spell check can highlight pieces of code sometimes if you just open a markdown file in a silly text editor which doesn't know what markdown is. And in markdown, you have very basic semantics for spell checking. You could say ignore letters between backticks because we know it's some kind of a code phrase, code word, and ignore lines between three backticks because we know it's a code block. So spellings in there are not necessarily going to adhere to any spelling in a natural language. But in DITA, we have many more options. we can specify a list of tags where we want to ignore spell checking. So it could be, code phrases and code blocks, could be API names, file paths, options, and then, we can opt in and out. For example, in our documentation, options need to be spell checked versus in some other documentation, they do not. Maybe you can add a keyword with a specific class name, which is, omitted from spell checking, and you can train your spell checker to honor those settings. And you can also say, ignore these tags except when they have a particular attribute, or you can say in certain XML contexts. So for example, you could say option within a parameter list, we don't want to spell check, but an option in a task, we want to spell check. So here's an example of running a spell check test, which was very simple to write. This one tells us perfect spelling in our DITA files, reference.dita perfect, task.dita perfect. And then we're running the same on the files after we broke them a little bit. And this particular test tells us that we have some misspellings. You can check out this example on GitHub after the presentation. Download it for yourself and see what the examples were, how we wrote these tests, and think about how maybe you could apply them to your own situation. But wait, there's more semantic testing that you can do with DITA, because these tests that we talked about so far require some form of software acumen, some coding skills, even if they're basic, like mine. You still have to have them, because you are writing tests kind of as if you were writing software tests, right? So you have to think about the situations that your documentation could be verified against a piece of software, and then you have to integrate with that piece of software and write those tests. So you're basically programming. However, there are some semantic testing methods which are more native to the technical writing skills stack, and which more technical writers should be able to do without too much trouble. Schematron. Schematron is one of those ways, because it uses XML to verify DITA XML structure, right? So you remain within the world of XML. If you're an XML writer, maybe you know some XSLT, XPath, and things like that. That's great. You don't have to learn any other skills, because using Schematron, you can rely on what you already know. So here are some examples of what you could run. And in our test suite at Guidewire, we actually have about 50 of those tests. I'm sure Michal could correct me if his audio was working. But there are very many different things you can do, and you can even enforce your style guide and your technical writing practices using Schematron, because it's going to look at the XML structure, and then you can also look at phrases, excuse me, phrases in certain contexts, and you can look at like enforcing rules like don't use the word should in narrative text or something. And at the same time, maybe ignore the word should in a piece of code because it's used there as a keyword in some programming language. So here are some examples of semantic tests. No list should have only one element. For example, maybe you have a rule like that. Over the years, someone's been maintaining a doc and removing bullet points with say, for example, features which we don't support 6 bullets. Next year it's 5 bullets. Next year it's and you end up with a list of just 1 bullet. The test tells you it shouldn't be a list anymore. Turn it into a paragraph. Maybe you have a rule that says no empty tags, and then after you convert some Microsoft Word files into DITA, you have a lot of empty tags. This test will tell you, here are some empty tags, you can delete them. You can say use / inside file path instead of \, because, for example, you favor Linux/macOS paths in your documentation, and somebody sometimes will insert a backslash. You want to correct this. You write a schematron validation for that. Schematron also has a feature called quick fixes, which allows you to write simple transformations that help you to correct the problem. And in Oxygen XML editor or Oxygen XML author, you can see these quick fixes, and you click the little light bulb or press Alt+1, and you can apply those quick fixes. So they could, for example, if you say no list should have only one bullet point, you can run a quick fix that turns this list into a paragraph, for example. Or maybe you have a few options, like turn it into a paragraph, or turn it into a section with a paragraph, or turn it into something else. This is how you write quick fixes, which is not programming by any means. It's just the quick fix XML specification that tells you what you can do and how you can do it. So you create a title for the quick fix that is visible in the editor, and then you have a set of actions available to you. For example, replace, and then you use a variable, replace it with h1. And it's not much different to writing any kind of XSLT transformations or anything else you would be doing with DITA. Okay, I think we've come to the end of our presentation. I know we've been collecting questions in the chat if you've had any. So let's take a look at those now.
Yes, that was perfect timing, but I don't see any questions. So I would just like to remind you that you can go to the questions panel, and you can post your questions there, and we will ask our presenters to answer them. Actually, I have a question. What were do you have any sort of metrics and a sort of KPIs that were related to the to these semantic checks? Because yeah, I guess that might be a case that somebody is is going to introduce them and is going to show the management that how better is the situation with these checks.
Yeah, that's a perfect question, and we have started implementing that. It's not the highest priority yet. We're stabilizing the pipeline, but we have we set up an instance of Kibana which collects the state of all the documents right now. So every time a document is built, the tests run, and it saves the build result in Kibana, and we can see what the status is. For example, 60% of documents have problems, or we have so many problems. Or we could drill down into a particular section. For example, we could say documentation for this product. Here's the number of errors. You can look through these errors, what they are, and you can start fixing them. We want to work on some kind of like you said, health metric over time that shows us, for example, we're improving, or or our docs remain perfect. They remain green for X amount of days, and we want to, if we see there's a problem, we can maybe implement some more checks on the linting stage so that people don't commit problems, right? This is definitely a very good idea, and we want to pursue that.
Yeah, we have a question. Would you say this docs as code approach has any use in other than software documentation?
Yeah, that's a tough one. It's probably a good topic for a whole separate presentation, but it's a good question. I will try to answer it as best I can. I don't have that much experience in the machine and robotics industry, but I do have some. And I would say it probably doesn't make sense to maintain docs as code if you don't have code, but it makes sense to streamline your delivery pipelines and your workflows. So if you can automate stuff, automate as much as you can. So naturally, if you don't have software, you will not be able to run a test against a factory machine or a robot or something like that. But if there's anything you can do with these docs that can validate against something else, it's also worth doing. I'm not even mentioning, you know, automated builds and CI/CD pipelines, because that's a given. Like, you should always be doing that with docs. But for example, if you're writing instructions for vehicles like buses or whatever, you know, cars, any kind of vehicle, maybe there's some other documentation that you can verify your documentation against. So for example, maybe there are engineering specs somewhere, and they maybe list numbers of features, or, you know, possible error messages on the dashboard, or the weight of the engine, or something like that. And you can probably run some tests on DITA, get that information from a database or from some other source, and check if your information is correct.
There's another question. It's actually a request. Could you please add the download, post the download link to the examples? Do you have the link that you could probably share on chat with everybody? I think there was a GitHub link.
Sure, let me try to do that. I was under, was working under the assumption that we would share the slides later, but sure.
Okay. And I think we have another question, which is pretty much the same. Do you have a public Git repository with some example code? So I guess that's exactly the same answer here. This is the,
yep.
Okay, thank you for the link.
Okay, yeah, this is the repository. And then if you know, you can download it, you can fork it. If you have ideas, you can create a pull request. We highly encourage people to collaborate.
Okay, thank you very much for this link. Let's see if there are any other questions. I will remind you that you can continue discussing this topic in the event application. At the beginning of the chat session, you should see the link that will just lead you directly to the event app, and to that specific session. There is a section for further discussion on that topic. And okay.
From my side, if you guys want to stay in touch with us, I also encourage that. You can email techwriterkoduje.pl at contact, or you can find us on LinkedIn and connect directly with us.
Okay.
And here's the QR code for your for the poll, or for like the evaluation survey feedback for our presentation, right? So if you want, you can get your phone out, scan this QR code. I just realized last week that you can just, like, in modern phones, if you just open your camera and you look at a QR code, your camera now tells you this is a QR code, maybe I can scan it. So you don't even need a QR application.
That's correct. That's correct. So Paweł, Michał, thank you for this fantastic presentation. Thank you. Thanks to all attendees for attending TC World Conference and today's session. And as Paweł already mentioned, you can either scan the QR code and to open URL and provide the feedback for this session, or you can use the link that is going to be displayed to you right after the session is finished. And we would appreciate if you would take the time to leave the feedback about the session. And the recording of the session will be available for 3 months, and the recording can be accessed via your dashboard in the conference tool. And I hope you enjoyed this session, and yeah, have a good evening.
Thank you, everyone. It was a pleasure speaking to you.
Thank you, Michał. Thank you, Paweł. Thanks a lot.